With number 2, my first step is to express this as a matrix. So I'm going to copy down all of my coefficients, but I am not going to write any of the variables. Okay, so I need to get this into row echelon form, and my step for that is the first step is I want to get a 1 here, but that's already been done. So that's good. Now I need to get zeros underneath it. So let's first try to eliminate that 2. So I can take row 2 and add -2 times row 1 to it to get my new row 2. So that's going to be like this. So I get 0, -9, +9, +18. So let's update that matrix. Okay, so I have the 0 in the second row. Now I need to get the 0 in the third row. So if I take row 3 and I add -8 times row 1 and make that my new row 3, then it should eliminate that 8. So let's add those up, and I get 0, -27, +27, and +54. So my new matrix is going to be 1, 0, 0, Okay, so my next step is, after I finish the first column, I want to get a 1 here. I'm trying to make that diagonal of 1s right here. So what I need to do, if I go to the next slide, what I need to do is I want to take -1/9 times row 2 to be the new row 2. Okay, so now that I have the 1 there, I want to get zeros underneath it. So I want to get rid of that 27. So if I take row 3 plus 27 times row 2 to get my new row 3, this will be 0, -27, 27, 54, 0, 27, -27, -54. So if I add these up, I get 0, 0, 0, and 0. So I actually get a row of zeros here. So let's update our matrix. So this is our REF form. Again, it is okay to have the row of zeros there. That's still technically in REF form. Now, I do want to convert this back to a system. I'm going to show that on the next slide. So this is going to be x plus 4y minus 2z is equal to negative 3. Y minus z is equal to negative 2. And 0 is equal to 0. So because this is a true statement, this is going to be an infinitely many solutions. If you had a false statement, like 0 is equal to 7, it would be no solution. So in your matrix, that would be 0, 0, 0, 7 instead of 0, 0, 0, 0. So if you ever run into that, that would be the no solution case. But here, this is the infinite solution case. And for infinite solution case, they still want you to write it as a ordered triplet. So this is where I'm going to put that z can be anything. And I want to work my way back up the system and get everything in terms of z. So y minus z is equal to negative 2. If I move the z over, y is equal to z minus 2. And then I want to plug both those into the top one. So I have x plus 4 times z minus 2 minus 2z is equal to negative 3. So x plus 4z minus 8 minus 2z is equal to negative 3. This will be x plus 2z is equal to 5. And x is equal to negative 2z plus 5. So my final answer will be negative 2z plus 5, z minus 2, and z. Or they could potentially want you to use t, like they've done before. That would be negative 2t plus 5, t minus 2, or t. So it's just depending on what variable they want you to use for the parameter. Either one of those should be okay. So it is an infinite solution one. Again, they still wanted the row echelon form, but then this will be our final answer.